Hi, Nick Booker here, and I'll be talking about different ways to simulate water in video games in this video. So here I'll examine two approaches to simulate water. The first approach uses the Navier Stokes equations to implement an SPH, or a smooth particle hydrodynamics algorithm. This algorithm takes as input water properties such as both viscosity, mass, and resting density, as well as the pressure constant and weighing function constant from the SPH algorithm. As output, the SPH algorithm produces an acceleration value that's derived to find the new velocity and new position for each particle. So these variables can all be found over here. With this approach, each particle must know its immediate neighbor particles. And to implement this, a hashing function is used to update a dictionary that contains the coordinates as keys and lists the particles that occupy each coordinate as values. And the colors of each particle seen here they're showing what coordinate each particle is in. So while I learned a lot about how to organize objects using hashing, and I was introduced to the SPH algorithm, I found it difficult to get correct values for all of the water properties on the right. And as you can see, the simulation was running very slowly, and this is just on my laptop using 50 particles. So after attempting this, I wanted to make better looking water, and in order to do this, I decided to use shaders, particle effects, and procedural meshes to design a more realistic and performant, although not as entirely physically accurate, as this water simulation. So I'm going to stop this here and switch over to that other scene. Where you can see there's a river and a waterfall, and when I run this, the textures will move in different varying directions to give a water effect. Now, the mesh is also being offset by layered Perlin noise, as is shown with the movement of the mesh up and down in varying positions. Now, in order to get the water to look like it is fading to a different color into the distance, I'm using a Fresnel effect, which is the dot product from the camera to the mesh normal. And that will grow in intensity as it approaches the edges of the mesh, giving an outlined look for certain situations. This is often used for selection. For example, in menus, where you can select different objects, you could use a Fresnel effect for that. So this approach is significantly more performant, as can just be seen by the frame rate here. And you can see the waterfall. I'm using another water shader in addition to particle effects that simulate splashes of water and the fog from the water hitting the rocks. So all the 3D models in this project were created by me, with the textures coming from mostly textures.com, and they're all royalty free. So thank you for watching. Bye.